questions about any of that stuff? We have this nice little number called E that we're going to be working with a lot. This E represents, it's just a number, just like pi is a number. But we use it a lot when we're dealing with natural logs, and we will be dealing a lot with natural logs, and we'll talk about what that means a little bit more in a little bit. But for right now, we're just figuring out, well, how do we type this stuff in our calculator? So when you get ready to figure out how to do e to the third and you're raising it to whatever power, we're going to go to our graphing calculator. And if you look on the first row of buttons, if you see LN, it's like the third button from the bottom, right above it, there's going to be an e raised to the x power. So let me get out of here real quick. So I would do second LN, and then I can raise e to whatever power I want to. So e to the third, 20.0855. E to the 0 should be 1, because anything to the 0 is 1. Okay, so e to the negative 0.23. Okay, so you kind of get the hang of what you're supposed to do there. You're just typing those in and rounding them to 4 decimal places. So this is what you should be coming up with on this part. So 20.0855. E to the 0 is 1. 0.7945 and 2.71. I'm raising this to the first power, so we're just talking about this number right here. 2.718 won't be a 2, it'll be a 3 if we round it to 4 decimal places. Everybody okay with where you come up with E on the calculator? Okay, because that part's pretty easy. So we've got some graphs here that they've just graphed E for us. Just remember that this is, I mean, we've looked at graphs like this, y equals 2 to the x. Well, e to the x is just, it's very similar to that. It's just that 2.718 ... to the x power. So it's just an exponential function that is going to be increasing. But if I say e to the negative x, okay, now we're going the opposite way. And it looks like what's happened if we raise this to the negative x is that we flip this across the y-axis. If we raise something to the negative power. So that's all that's done there. Those two are shown to you. The last thing we're going to talk about in this lesson is matching these. Okay. And one more thing, I'm going to pull up your homework, and I want us to look really quick at a couple of tricky parts on this homework. Okay, here's what I want you to notice. This 3 should be easy for us to pick out, because this e to the x is just 2.7 something raised to the x power, so exponential growth. And what would the plus 3 do to this? Anybody on chat know what the plus 3 is going to do to our graph? It's going to go up 3. You are absolutely correct. So I think that that one would go with E, because it looks like this is exponential growth, and it looks like it's been shifted up 3. So I'm going to say that this is E. I'm just going to kind of mark through this one because I found the answer to that. Okay, this one we also should recognize, because if it's up here with the x plus 1, it's supposed to be the opposite of what we think, and it's supposed to be left or right. So I really think that plus 1 is going to move it to the which way? Left 1, but it's still exponential growth. We're just going to push it to the left 1. So I kind of think B on that one. So it's going up, but we're kind of pushing it back 1 space. Everybody okay with that one? Still exponential growth, but we're kind of pushing it back 1. Now, your calculator can show you these. I'm just trying to, if you were trying to reason this out, what would you do? Okay. This one, we haven't talked about this, but this negative in front is going to flip this thing across the x-axis. So it's going to be flipped across the x-axis, and then the minus 1 would take that and push it down 1. So we're flipping something across the x-axis, and then we're pushing it down 1. F. Yeah, that's right. flip, because what we've done is we started with something that was going this way. We flipped it across the x-axis and then we pushed it down one, right? So this one right here, this one's also flipped across the x-axis, but what we started with was exponential decay. So it was starting like this, starting with something like this, flipped it across the x-axis. We didn't push it up or down. So I'm going to say if we had exponential decay, it would look like this. And if all I did was flip it across the x-axis, see? So if this one right here, the negative part, if it's up here, we're flipping it across the y-axis. So we're flipping something across the y-axis that was exponential growth. So it started out like this, then we flipped it across the y-axis. So we're flipping it across this axis, and then we're pushing it down too. So just imagine if I started out right here and it looked like this, I flipped it across the y-axis, and then I pushed it down too. So you see that? Flip it across the y-axis, push it down too. That's going to be A. So 6 has to be D. And if I were going to do 6, I would rewrite it with the exponent in the front. So negative e to the x plus 1. So I know this negative is flipping it across the x-axis. So it started out exponential growth, and then it flipped it across the x-axis. So we started out with this, and then it pushed it. Then we flipped it across the x-axis, and then it pushed it up 1. So D. If I'm taking a test on this, I'm absolutely typing these in the graphic calculator.